All right, welcome back, students. So we are going to start shortly. We're about to begin. We're going to pick up from this morning. So this morning, Mrs. Fenton went through the trig ratios, where we start, what they are all about. And we ended up looking at angles of elevation and depression. And could we just look at the slide just before, please, Mr. Leamy, with the, we want to remind you before we go right in that we have our YouTube page as a math team, where you can look at our previous workshops, both for, and if you have a child, if you have a younger brother or sister, there are also material there for grade 6 students. So you're welcome to go to our YouTube page and our YouTube channel rather, and be seeing what we're doing in our math section for our math for both high school and primary school students. All right, so we were looking at the angle of elevation for this dog looking up at the bird in the tree. And we also saw that the bird looking down at the dog, there was a corresponding angle of depression. So for both animals, we can see that the angle of elevation would be the angle between the horizontal and the line of sight to an object that is above the horizontal. So notice that the dog is looking at something above him, while the bird is looking at something below him or it. All right, so let's look a bit more at the terms that are associated with angles of elevation and depression. Another example might be an observer in a boat or at a lighthouse or in a ship, in a plane looking down at somebody or someone looking up. Either way, notice that the person on the ground level or at the sea level is looking up at the aeroplane. And notice that the angle of depression and the angle of elevation forms what we call a Z. We loosely call it Z angles. They're actually, the real math term for them is alternate angles. And these are alternate interior angles because they're formed inside the horizontal lines and on opposite sides of the transversal. So the transversal is that slant line that is between the two horizontal lines. So these are alternate interior angles. And in geometry, those two angles will always be equal. Alternate angles are always equal. So you'll find that that angle of elevation is equal in value to the angle of depression. So if somebody were in the plane looking down at the man in the ship, the angle of depression for that person looking down at the person in the ship is the same as if that person has the same angle as that of the person in the ship looking up at the person in the plane. So those corresponding, those angles, I will not say corresponding because it's another type of angle. Those two angles are equal for any two observers in two different positions, whether from the plane or the ship or vice versa. You can move, okay? So let's take a moment and type in the chat. Let's look at this little diagram with the angles 1, 2, 3, and 4. I would like you to classify each of the angles as either angle of elevation or depression. Type in the chat. What would you say is angle 1, all in relation to the man? What would you describe angle 1? Type in the chat whether it's an angle of elevation or an angle of depression. Okay, so for the man, is the man looking down at the bird? Okay, so angle 1 for the man so the bird is looking down at the man. All right, so for the bird, he's looking down at the man. All right.
Let's remind, Ms. Harris, remind us that horizontal. That is
right.
So if it's below the horizontal, whomever is looking, whichever point of view it's coming from, below the horizontal will give you a depression. Above the horizontal will give you
an elevation. So thanks for that added dimension. So students, are we seeing? So is the man looking up at the bird or down? Is the line along with the man is looking at the bird? Is it above the horizontal or below?
Above.
Above. All right, so angle 1 would really be an angle of depression for the bird. Fine. But what would it be for the man? Just out of curiosity.
Elevation.
Elevation. Good. So for the man, it's an angle of depression for the bird looking down at the man. And what would you describe angle 2 as?
Elevation.
So bird to man, I see Deshaun saying that bird to man is angle of depression, man to bird is angle of elevation. Did you say elevation a while ago? Was that Abriana?
Yes, miss.
Okay, so Abriana is saying that it is an angle of elevation. All right.
Miss?
Yes?
Miss, could you repeat what you said earlier about the horizontal line?
So the horizontal line is we always measure angles of elevation and depression from a horizontal. So you take the person looking at eye level straight across, that's your horizontal. If I start to look up, that means what I'm looking at is above me. And so it's an angle of elevation. But if I start to look down at my foot, then it's below and therefore it's a depression. So the angle of depression would be below the horizontal. So Sarah, could you just quickly put the slide where we have the definitions, please? And the person can, whoever asked that question can probably quickly take this. You could probably take that. You want to take a pic of that? It's the angle between the horizontal and the line of sight to an object above the horizontal. So elevation will always be looking at something above your horizontal, looking up, while depression will be looking down. Is that clearer now?
Yes, miss.
Great. All right. Thank you, sir. We can move on. What about angle 3? What would you say about angle 3? Any thoughts on angle 3?
Miss is an angle of depression.
Depression.
Okay, depression.
Depression.
All right, and it's looking, the man looking where?
Down to the
Down
dog.
at the dog. Okay. And what about angle 4?
Angle of elevation.
That's from the dog to the man.
Correct. So the dog is looking up at them. The dog would have to look upwards to see the man. Curiosity question. What would we say about the cat on that low-lying limb?
The cat is looking straight at the man, like the horizon line.
So both of them are they're on each other's horizontal. Okay, fine. Thanks for that. So are we more comfortable with our elevation and depression? Or remembering about our elevation and depression?
Yes, sir.
Anybody not clear? All right, so we can move on then, sir. So let's look at how we can use our trig ratios when we have an angle of elevation or an angle of depression. So here we have an example. Olivia is in a lighthouse on a cliff. She observes 2 sailboats due east of the lighthouse. The angles of depression to the 2 boats are 33 degrees and 57 degrees, respectively. It's not there, but typically. So there, this would be the diagram that we have. All right, so sometimes you'll be given the information and you might be asked to finish the sketch or draw a diagram that represents it. So do we see what represents the lighthouse? What line segment you think represents the lighthouse and the cliff?
CD.
CD, okay, great. Tell me something more now. What represents the distance from ship B to the foot of the lighthouse, or the foot of the cliff, I should say?
Miss, repeat the question.
What line segment represents from ship B to the foot of the cliff?
DB, miss.
DB or BD, good. So I see someone using the real life, and somebody saying that as the same name states in real life, when you're depressed, you feel down in spirit. So maybe that can help us. We're looking down because we're feeling down when we're depressed. Thanks for that. Who was that? Abriana? Okay, thanks for that, Abriana. Are we clear on that, everyone? And when you're up in spirits and you're elevated, your mood is elevated, you're going to be looking up. So our question is asking us to find, I believe, can you just bring up the question? But we're going to look at now, what would be the distance between the two ships? What's the distance between the two boats? Now, before I go to the distance between the two boats, can anyone tell me why that angle if there is measured as 57? Why is that? Why is that the 57 isn't between the cliff and boat B? Any thoughts on that?
The angle is from the girl looking down at the ship B, so like it would be between her horizon, which is CE, and CB. That's what I understand first. I'm not sure.
All right, so CB. So which one is a bigger angle based on the question we've been given? Which is a bigger angle? 57 or 33?
57.
All right. So the 57 is a bigger angle. Think about it now. Why is it that we didn't put the 57 between CE and CB? Any thoughts? Why is it that 57 wasn't for between CE and CB? What do you
Oh,
think?
okay. So it's both angles combined. No,
Okay,
never
so
mind. Sorry.
look at that
No.
57 degrees. 57 is a bigger angle, right? Which ship is nearer? Ship A or ship B?
Miss Ship A.
Ship A is nearer, okay? All right. So how comes we didn't put the smaller angle for the nearer ship? Any thoughts?
Mr. Leamy, can you reveal the other angle?
No, not yet. I just want us to see if we could see why we put the bigger angle for the nearer ship. If you're standing up somewhere and you're looking at something a little distance away, do you have to lower your head more or do you have to lower your head less if you're looking at something at your toes? Which one you have to lower your head more for?
You can do the exercise right there. Sit up straight in your chair, stretch out your arm, look at your fingertips, and then look in your lap. What do you notice? With the movement of your head, that is.
And then look at something that is a little bit away from you. Look at something on the ground on another side of the room. Do you have to lower your head as much? Talk to me. You have to look down, fine. You have to look down in both cases. Look at something across the room from you. Do you have to look down as much?
No, miss.
Okay.
No,
What
Miss.
does that tell you then?
Miss, for the objects that are closer to you, you'd have to bend, like the angle at which you have to turn your head would be lesser than one that is further away.
All right. That's what happened to you a while ago?
Think about it again.
Think about it a little bit more.
On the right track, you know, but
You're on the right, yes.
Miss, the one that is furthest away from you, you wouldn't have to use as much tilting, but it's the one that is closest to you that would require more of you to go further down to try to see the object.
awesome.
Okay. But thank you for saying that, Abriana. Is everybody seeing Abriana's line of thought? She's saying that if I have to look, the closer the thing is to me, the more I have to lower my head. In other words, the greater will be my angle of depression. So sometimes, and very often in CSEC, they ask you to do a diagram and they ask you to insert the angles of depression or elevation. So notice that angle 57, which is the larger angle, is for the nearer ship. Now you can reveal the other one, please, sir. So if you notice, the 57, which is the larger one, is for the nearer ship. The 33 degrees, which is for the ship that is farther away.
33.
What did I say? 50? Oh, yeah, thank you. The 33 is for the ship that is farther away. So if they ask us to find the distance between the two ships, or the two boats, boat, ship, whatever is the technicality, I don't know. If you notice, what do you notice about triangle CDB? Is it a right triangle?
Yeah.
Yeah, it would be a right triangle,
Yes,
isn't
ma'am.
it? So they're both right triangles. CDB and CDA are both right triangles. And so, how could I find the distance between the two ships? I would first find the length of what you think. I'm going to find the length BD, and then I'm going to find the length DA. Can everyone see that? In order to find the length of AB, I must first find the longer distance, which is DB. Then I find the shorter distance, which is DA, and I do a subtraction. I find the difference. That will give me the distance between the two ships. And of course, notice the 57 and the 33 at the top, but what did we just learn?
Miss, that is going to be the same thing.
That is going to be the same thing. Somebody's in the boat looking up at the girl on the cliff. Where would that where else has a measure of 33 degrees? I'm seeing someone asking to explain the 57 again. There are two angles given, Danny. They said the depression for two boats are 33 degrees for one and 57 degrees for the other. And we're finding out that if I'm to look down at my toes, I have to lower my head a lot more than if I'm looking at something across the room from me. So if I'm looking at something on the ground over at the table or somewhere away from me, I don't have to lower my eyes as much as if I'm looking at something in my lap or something at my toes. So the greater angle of depression, I have to lower my head more for something nearer than for something farther away. Is that better than A? Okay, great. So notice sir has shown you your alternate interior angles. Notice that the 57 for ECA is the same as DAC. Remember, when you name your angles, the middle letter is always where your vertex is. So DAC is the same size as angle ECA because they are alternate interior angles, and alternate angles are equal in measure, equal in size. And as we said, the nearer the object, the larger the angle of depression.
Miss?
Yes,
Before you
Abia?
erase, so the 57 degree at CE is outside, but at DA it's inside, and I realized that there's also 33 degrees, but I don't know where that comes from.
That 33 is because the two boats are at two different angles. The two boats are at two different angles.
So Miss, the 33 degree would be for B because it's furthest away.
It's further away than A, correct.
Okay, Miss.
So the smaller angle is for the object that is further away. All right. So if I wanted to find length AB, I find the longer distance and I take away the shorter distance. And that's how I'd find the distance between the two boats. Okay? Any questions on that?
What do you say about to take away to find the distance again?
I'm trying to find the distance AB between the two boats. AB is my distance between the two boats, and I'm trying to find that distance. So in order for me to get that distance, I have to first find the longer one, which is DB. Then I find the shorter distance, which is DA. And I do a subtraction. So I'm going to ask a quick question before we move on. Based on what we've said, we know that angle CAD is what again? 57 or 33?
That's 57.
57.
Okay. So
57.
57. All right. So now that we know our trig ratios, how could I find the length DA? What would I use to find it? Type it in the chat what I could use, or raise your hand and open your mic, whichever one. Whichever, if I see a raise hand first, I'll go with that. If I see typed in the chat, I'll go with that, either one. How could I find the length DA? I'm seeing cos and I'm seeing tan. The person who said cos, tell me how you would use the cos if I want to find the length DA.
Well, Miss, I was trying to figure out so I know that there is the hypotenuse, and I was thinking that opposite from the hypotenuse would be the adjacent. And then I was thinking of the soccer
just a
tower.
second. Say it again, Abriana, please.
Yes, Miss, I was saying that I know that CA is the hypotenuse.
Mm-hmm.
And I was saying opposite from the hypotenuse would be the adjacent.
So when you say opposite from the hypotenuse, what is opposite to the hypotenuse? It's an angle.
Oh.
So whatever is opposite to the hypotenuse is an angle, but it's opposite to the 57 degrees now would be the CD. But Abriana, a quick one. Do I know the length of the hypotenuse CA? Remember, you look at what you know and what you need. Do I know the length of the hypotenuse?
No, Miss.
No. What do I know in this diagram?
Miss, the 90 degrees and 57 degrees.
And what else?
The length of CD.
Miss, the length of CD.
The length of CD. So for my right triangle, I know that whole length CD as well as the angle that is facing it. So I know an opposite and I know angle, and I want to find what? What side am I trying to find? DA. Is DA, is it opposite or adjacent to the angle?
That's
Miss, is it adjacent?
It's adjacent. So I know the opposite, I know an angle, and I need an adjacent. Which ratio would use the O and the A?
Tan.
Tan. So I'll use my tool to find my DA, and I would calculate the values. Probably won't do the full calculation now, but that's exactly what the approach would be. Any questions on that?
yes, Miss. No, Miss. Sorry.
And so we would do similarly. What would the other angle that we'd be working with? Angle what? CB. CBD, which is going to be 33. And by the way, student, sir is drawing out the triangles. We always encourage our students to isolate the triangle. When you have more than one triangle in your question, pull out the one that you're working on for that part of the question. So notice that sir highlighted triangle CDA. Now that we're ready for the other triangle, we're going to highlight triangle CDB, because this time we're working with the 33-degree angle. And we walk through the same calculation again. Or would I? Let me not jump to conclusions. Would I go through the same calculation? What are your thoughts?
Miss, before that, how you found the adjacent for the, so I get how you found the opposite, which is the 57 degrees is opposite to, but the adjacent, Is it because it's right beside of?
It's the one that's closest to, or right. Who is your neighbor? Isn't the person adjacent to your neighbor, right next to you? So
Yes,
the
miss.
side that is right, once we don't think about the hypotenuse is there on its own. The side for the angle that we're discussing, the side that is nearest to it would be your adjacent side. It's the neighboring side. It's the one right next to it.
I like that term, the neighboring side of the angle, though, of the angle. Remember?
For the angle, the side that is nearest to the angle, don't think about the hypotenuse though. The hypotenuse is, I wouldn't say standalone, but when we're talking about our opposite and adjacent, the hypotenuse does not come in. All right? So for this time, I'm trying to find dB. Again, I have what? I have an opposite side of 195. I have an angle of 33 degrees. And I'm wanting to find dB. Is dB the hypotenuse? No. dB is what side? It's what? What side is it in relation? It's adjacent. Excuse me. That's right. So since it's adjacent, what ratio will I use to find that length dB? Oh, my not hear Tan just blow me up, like kill me over with Tan. Right, Tan, I'm seeing some Tans in the chat. Are we clear now, students?
Miss Question, are we doing the 33 degrees now or still the 57?
No, we're doing the 33 now because now we're looking at dB. Notice that we're looking at the longer distance now, dB.
Oh. So this one was DA. The one
one
yes.
was dB, correct.
57. Yes, miss.
Correct. This time now we're finding dB, and then in order to find the length AB, I'll now have to do a subtraction. All right, so that's the approach that you would take. And we can do that calculation, and it will, but we won't do it now, but that is how you find the distance between the two boats. Any questions on that?
Miss, so how would you know not to use the hypotenuse, seeing that the degree is still, the degree is still, the 57 degree is kind of close to the hypotenuse as well as the adjacent. So how would you really know which one you're using?
All right, then. So think about what you need and what you know. Do I know the hypotenuse?
No, miss.
Okay. I know an angle. Are you better now?
Yes, miss. So it's basically whatever you know, you would use that to best to determine which trig ratio to use.
Correct.
Okay,
so since I know an angle and the side opposite to the angle, and I need to find the side that is adjacent. If, however, Abriana then asked me to find how far is ship A from Olivia, what do you think I'd have to use? Could I use the tan that time?
No, miss, you use the cosine.
Sure. Do I have the side adjacent or do I have the side opposite? So just highlight it for me, please, sir. If they ask me to find CA, which is the hypotenuse.
Oh, this sine ratio, miss.
Aha, there you go. I'd find the sine, use the sine ratio. Because I know a length opposite, I know the angle face, the angle and an opposite side, and I want to find the hypotenuse. But this time I'm not trying to find the hypotenuse, I'm trying to find the adjacent. So since I know an opposite and an angle and I need the adjacent, then I will use my tan ratio.
So miss, the adjacent would be 90 degrees?
No, for the 57.
Yes, miss.
Look at the 57 degrees, which side is nearest to the 57? So just a quick point, I won't say never, but you rarely, I can't think of a time when you work with your ratios in terms of the 90-degree angle. It's usually in terms of the acute angles. So you rarely ever think of your opposite and adjacent in relation to your 90-degree angle. Your opposite and adjacent is typically in relation to your other two angles in your right angle. So your opposite to your right angle is the hypotenuse. Those two, you kind of take them out of, you don't factor those in at the moment. No, I shouldn't say that. Because if I'm dealing with sine, I would use the hypotenuse. But when I'm talking about the sides that I'm talking, when I talk about opposite and adjacent, it's always in relation to the angles that are not right angles. So I wouldn't ask for the sine of the 90-degree angle. I would ask either for the sine of the 57 or the sine of the 33. Look at that, those are complementary. All right. So I wouldn't ask for the sine of the 90. Not typically. I shouldn't say I wouldn't, but I typically wouldn't ask for the sine of the 90, which would be 1. Okay. Any other questions in regard to that? All right. I'm not looking at, all right. And you can go on then, Sir Limi, go ahead. All right, so let's look at this triangle. Based on what we've looked at from morning, which of the topics, subtopics, concepts we've looked at from morning would you use to find the length y? Type in the chat for me or raise your hand. What would we use to find the length y? Yes, Jaden?
The Pythagoras theorem.
Great. Anybody agrees or disagrees? I hear Pythagoras theorem, Pythagoras theorem, or the Pythagorean theorem. And I would agree. Go ahead then, sir. It is the Pythagorean theorem or Pythagoras theorem. Since you know two sides of a right triangle and you want to figure out the third side and dealing with lengths, I just use my Pythagoras theorem. Okay? Ah, I see the argument coming in now.
Miss, I was asking that the reason for using it, would it be because they didn't give us a angle?
Yes, because to go and use an angle, then you could use an angle and then find a side, but that would be like such a long journey. Because I could have used go and find the angle, but I don't need to do that. I can just use my Pythagoras theorem to just use the lengths. Once I know lengths and I work with primarily lengths, you just usually would use your Pythagoras theorem. If I'm just working with lengths, I know two lengths and I need a third, I use Pythagoras.
Okay, miss.
All right. Okay, so I know two lengths of a right triangle and I need to find a third, then I would just use the Pythagoras theorem. So just to recap, the Pythagorean theorem or the Pythagoras theorem is a tool for right angle triangles. Right triangles, I cannot use it for a triangle that is not a right triangle. It's only for right triangles, okay? And when do I use the Pythagoras theorem? When I know two sides, whether it be the hypotenuse and one side, or two sides, whether it be two sides, and I need to find what sometimes people call the legs, the vertical and the horizontal. Well, I shouldn't say vertical, it doesn't have to be vertical and horizontal. Once I know two sides and I need to find a third, then I'll use Pythagoras' theorem. Okay? And just to recap, what is the theorem? That the square of the length of the hypotenuse. And as I said, some people call the A and the B legs and C the hypotenuse. The square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides in words, which we don't bother to remember, we just write a formula. So it's A squared plus B squared is equal to C squared. Quick now, what concept would I need to do for this one now? What do I know? What do I need? Type in the chat or raise your hand. What do I know? What do I need? I see a sign coming in. I see sign, sign, sign. All right. Who would like to tell me why it's a sign, why it's sine and not cosine? We have hypotenuse and we want to know the opposite and we have an angle. I think that was okay, because you have to find opposite and you have hypotenuse. Great. We have an angle we are trying to find the side opposite to the angle, and we've been given the hypotenuse, which ratio has in the OH sign. Beautiful. Great. I think we're getting the hang of this. So great. Thanks for that feedback, Danae, Justin, and the others who are agreeing. All right. What about, so we've used our trig ratio, since we know it's a right angle. True, we know it's a right angle. We know that we have one angle that is 25, and we want to find the opposite side to the given angle. And so the trig ratios, we use them when we have a right triangle, and we want to find either the sides or the angles. So go ahead, sir. So when do I use the trig ratios? When I have a right triangle. So it's a right triangle, and I know the length of two sides, and I need to know an angle, just what we mentioned earlier. So like we had the opposite and the hypotenuse, I want to find an angle. And we can also use the ratios when we have an angle on a side, length of one side and an angle, and I need to find the other side. All right. And we did a bit of that earlier on. And the most commonly used trig ratios at your level are the sine, abbreviated sin, cosine, abbreviated cos, and tangent, abbreviated tan, which you're all familiar with. And we've looked at the ratios here, just summarizing what we looked at since morning. All right. Great. So another time we look at the trig rules, we won't look at those today, but we're gonna see that those rules also have sine and cosine in them, but we won't look at them today. We're just gonna go, those trig rules are used for non-right triangles mostly. But what we've looked at this morning are right triangles, which will use our trig ratios. All right, so I think we can go into the questions now. Any questions from any of our students before we look at?
I think,
what?
yes, sorry about that, Carol, for cutting you off. But yes, we are going to go through to the questions. But can we hear from everybody out there? Are you better able to read a question that requires either Pythagoras theorem or one of the trig ratios? Are you now better able to engage yourself with the question and choose accordingly?
Feeling more confident at your ability to choose the correct ratio, the correct approach? Okay, I'm seeing some yes, miss. Yes, great. And that's the aim of today, that you're better able to select what approach to use, what concept to apply. Because your CSEC looks for your ability to know not just what you know, but your ability to use what you know, and you're able to analyze your situation and use the best thing. So remember that you're looking at 3 domains. They're looking for your knowledge, they're looking for your application, and looking for your reasoning. So no point in knowing Sokoto and don't know how to use it. So we're glad that you're better able to know how to use it. Great, great, good stuff. Great. I'm loving these yes, miss, yes, miss. All right, okay. So just know the Sokoto, you need to know how to use it. All right, great. So let's see if we can look at a couple